So let me give the values. M1 is equal to I'll directly give the value of mu 0.2. You know, so the value of force. So at both the surfaces are rough. Okay, fine. This is for various values of force. The first case, I applied a force of 4 Newton. We'll discuss all the cases. I'm going to vary the force acting on the block M1. The mass of the block and mu is given. Okay, now what is the question like? Find the acceleration of the block and the friction at both the surfaces for various values of F. The first case is 4 Newton. Before that, what we should have the basic picture like this is N1, M1G, this is N1, and this is M2G, and this is N2. These are the normal contacts that are acting. Then first we'll calculate the limiting frictions at all surfaces. What is F1L? First, what is value of N1? N1 equal to M1G. Directly I'm writing N2 equal to M1 plus M2G. M1 is how much? 20 Newton. What about N2? Will be 2 plus 4, 60 Newton. Then we'll get the F1L, limiting friction at the first surface between the blocks M1 and M2. Should be equal to mu into N1. Mu value 0.2 into 24 Newton. Limiting friction at the block M2 and the ground, mu into N2. 0.2 into 60 will be 6 Newton. 12 Newton. Yeah, fine. Thank you. Okay, now these are the limiting frictions. What we have that one. So I think I already told you we must have the idea of limiting friction. No, I applied a force now equal to 4 Newton. Now I'm going to ask you what is the acceleration of the blocks and what about the frictional force acting at both the surface. The first time what happened, I'm bringing where the friction is acting at both the surface. Even the surface between block M2 and ground rough, between M1 and also the M2 is rough. What should be the direction of friction? As I applied force on the upper block, so the friction here will be like, I'll call F1 now. The friction acting between the block M1 and M2, let it be F1. And this will be F1. The friction now, this friction what will do, will try to shift the block M2 towards right. Okay, got this. As I applied force on the upper block. So therefore here, the friction will act on the upper block, opposite applied force F1. Then on the lower block, F1 towards side. This friction will try to shift the block M2. No? Therefore, the friction here on the block M2 by the ground should be backward. Okay, got this. So on the ground, it will be like this. Since we are not bothered to show on the ground, I'm leaving it. So as you increase number of blocks, you're supposed to use this method. Sir, F1, where is other force for F2? Because force will always occur in pair. That force, what happened by the block M2 on the ground will be in this direction. Is it okay? Fine. So this is very important. So this is what, this F2 is what? By the ground on the block. What is this F2? By the block on the ground. Since the ground will not undergo displacement, that's why we didn't bother to show this, and you need not to bother also. Sir, then why you are showing then this one? As this block is there, no? The block can undergo displacement. So therefore I have to show friction acting on block M2, F1. Then very next thing, what we are going to assume now. 4 Newton are applied. So what is F1L? Oh, again, the same value. Mu equal to, let it be, no problem. 4 Newton are applied. So is it block M1 can shift? Motion impending. So you can say that motion impending. So how much of frictional force should act here? Shall I assume 4 Newton? Then how much of frictional force here? 4 Newton. This 4 Newton, can it overcome F2L? Because for the block M2 to shift, what is the force needed? How much needed? 12 Newton, no? But how much is force is acting? 4 Newton. So therefore this F1, can it make the block M2 to shift? The answer is no. So therefore, what will be the value of F2? The F2 what will adjust itself to 4 Newton. So what is the net force acting on the system? Will be 0. What is the state of the block M1, M2? M1 blocks will be at rest. Got the idea now? First, the direction of frictions. Now you can ask question, sir, why you didn't assume acceleration? I think before going for whether the motion occurs or not, we have to check it. No, say similar thing. This F1 will become internal. This F1 will become internal. What is the 4 Newton? When the blocks M1, M2 will move together, because only when here friction acting will be equal to limiting friction. Then how much it is? It's 12 Newton. So therefore this 4 Newton cannot shift the block M1, M2, no? Okay, got it, no? So let's take the next condition. I'll make it 8 Newton. Second case, let F equal to 8 Newton. I'm just asking you to analyze here so that what happen will be easy for you. And the same values, the applied force is now 8 Newton. And this is rough. Then we have F1L, F2 value. 4 Newton, F2L is 12 Newton. I applied 8 Newton. This will be really very troublesome for you. What can happen to the block M1? Will it shift or not? Sir, 8 Newton here, F1. So I'll still call this is say F1. Let me assume like this. Is it okay? The assumption I'm making like this. I applied 8 Newton force. 8 Newton force, can it overcome the 12 Newton? Not possible, no? So therefore the F1 here, how much will adjust itself to F1L 4 Newton, FNL 4 Newton. This 4 Newton cannot overcome the 12 Newton. So therefore this will adjust itself to 4 Newton. So tell me, so what is this friction acting, static or kinetic? This will be static, no? F2 will be static. What about F1? F1 is limiting friction. And now what is the state of block M2? Block M2 will be at rest. It cannot shift. What about block M1? Will shift. Okay, clear now? So this should be the 8 Newton if I apply it. So F1 is how much? 4 Newton, and this will be 4 Newton. So what is the state now? What we can write it now? A1 equal to F minus FNL by M1. This is 8 minus 4 by 2. 2 meter per second square. Okay, let me make it 16 Newton. In the next case, see, unless you don't go for different values of F, what actually going on, it will not be possible. Huh? This will be the second case. F equal to 8 Newton. So let me bring third case. F is equal to 16 Newton. All the values are same. M1, M2, all the values are same. Then what is F1 value? 4 Newton. F2L, 12 Newton. These are the given things for us. Okay, now 16 Newton. So I'll tell you what actually student does. I'll just show it here. So here F1L, no problem. Here F1L. F1L is how much? 4 Newton, 4 Newton. And this will accelerate. Nothing wrong, nothing wrong. So here what happened, this 4 Newton cannot overcome 12 Newton. So therefore the friction here will adjust equal to how much? 4 Newton, and the block M2 will not shift. So this is what actually we may think like this. This is one thing. So this is what one of the student will think like this. Let me keep it as it is. Whether I'm right or wrong, one of the student thinks. One of the student thinks like this here. So whether it's right or wrong, all I think got erased. Anyway, recording is done. Okay, I'll continue here. So,